Hi everyone. Today we are going to be looking at solving quadratic systems, and I am currently looking at page 25 in our 0C packet. And we're just going to talk at the beginning about these different possibilities of what's going to happen when we have quadratic systems. So the first one I want to look at is two parabolas. So I have already brought up Desmos to show you a couple of ideas. So here on the screen, you see two parabolas. I'm going to sketch this right now in my notes because right now I'm looking at two parabolas that demonstrate a system and they have no solution because they never intersect. So there's no solution there. If I move the red one down, I can make it so that there is one solution. So here you see one solution. They touch once. So that is an example of one solution and a different view of two parabolas intersecting. Now, if I move it down even further, now there are two solutions. So I can also intersect twice. In the same way, you could intersect twice with a linear quadratic. Now, if I flip this one upside down, here's another view of what could happen in order to have no solution. So this kind of is like that parallel lines idea, but this one also has no solution. So it's kind of like a parabola inside of a parabola. All right, so there's your four different options for parabola. I'm going to go back to my notes so you can see what I've drawn here. I have the no solution that I showed you first. I have the one solution of them touching once, two solutions here, and then I have that other version of a no solution. Now I'm going to look at a parabola and a circle for my next section. So going back to Desmos, I have a parabola and a circle. So I'm going to start by moving my circle all the way to the side. Notice here you have no solution. So if you have a circle on the side or below, you could have no solution with a circle and a parabola. So next, if I move my circle over, you can also have that one solution. This could be done in many different ways. I'm not being really precise right now, but you can see visually that you could potentially get a one solution there. So there's another option, one solution. Now, if I continue to move my circle over, now you have two solutions. So there's another option there, two solutions. Now, if I move my parabola down, notice I can also make it so that there are three solutions. So there's the fourth option, three solutions. That one's kind of awkward to draw. So I've got a parabola. The circle touches the bottom, goes upside. And lastly, if I continue to move the parabola down, you can see four solutions. So the circle is just smack dab in the middle of that parabola. So going back to my notes page, here are all my drawings. Some circles better than others. So we are going to be looking at a potentially four different solutions to some of the systems we're going to look at today. So I'm going to solve one of these for you, talk about some strategies, and you'll do more in class with your teacher. I also want to point you to down here, where you could also potentially see quadratics that don't look a lot like what you've seen before. So there are ellipses, hyperbolas, things like that. We don't need to know what the graphs look like, just know that there's a potential for 0 all the way up to 4 solutions when you have quadratic. All right, so flip your page to page 26. And we'll just start right off with example 1. So something that I like to start with is looking at my variables. Now notice here you have x squared, y squared, and y in the top. I'm just going to write those over here. X squared, y squared, and y. And in the bottom, you also have x squared, y squared, and y. So instead of thinking about this as substitution, in general, we think of this as in our elimination mindset. So put your head in the elimination mindset. When you eliminate a variable, you're looking for same coefficient, opposite signs. So what's weird about this is there's not one clear-cut variable to eliminate, and you can't just pick one or the other and it's all going to be okay. So looking at this, I like to list out what my variables are on the side and look at what one section can I eliminate so that there's only one type of variable in there. So notice if I chose to eliminate the y's here, I would still have both x and y in my equation. So I need to get rid of these x's because then I'm only left with y's. So that's my only option. If I got rid of the y squareds, I would still have x squared and y. I can only solve an equation if I have one variable in there. So looking at this equation, looking at this system, I need to figure out how can I eliminate my x squareds. So I see x squared on the top and I see x squared on the bottom. So I need to multiply one of these equations by a -1. I'm going to multiply the top equation by negative. So my new system is negative x squared minus y squared minus 4y plus 12 equals 0. And on the bottom, I'm saying the same, x squared minus 16y squared minus 64y minus 80 equals 0. So now I'm going to add these together. The x's go away, and I end up with negative 17y squared minus 68y minus 68 equals 0. So at this point, honestly, I see big numbers. I'm going to go ahead, take my calculator out, and I'm going to double check, can I get rid of these big numbers? So the first thing I'm going to do is I'm going to see if 68 divides evenly by 17. And it does. So that means in order to solve this equation that now is a quadratic with y's only, I can divide both sides by negative 17 to simplify. So I end up with y squared plus 4y plus 4 equals 0. That's a lot simpler to factor than this right here. So just a little recap. I looked at my system. I listed out what my variables were. I decided what I was going to eliminate. I made a plan to eliminate, and I did. And now I get to a one variable equation that happens to be a quadratic. And I need to solve for y. So I'm going to factor and solve. So when I factor out, multiply up, I get 4. So this is going to split into 2y plus 2y. So I factored, and I now have y plus 2 times y plus 2. If you need a second to understand where my factoring came from, go for it. I did it quickly because we did it in 0C1, and hopefully you are all experts at factoring right now. So at this point, I notice I have two of the exact same factor. If I set y plus 2 equal to 0, then I get y equals negative 2. If I set this y plus 2 equal to 0, I still get y equals negative 2. So I only get one value of y. There's no sense in getting both of them because they're the exact same thing. So I get one value of y. And just like any other system situation, you take that value of y and you plug it in to find the other value. So I'm going to take this and I'm looking up at my original equations, and I'm going to use the top equation to plug in y equals negative 2. So I've got x squared plus negative 2 squared plus 4 times negative 2 minus 12 equals 0. So notice now I've plugged in y equals negative 2 for each y in the equation, and now I'm going to solve. So I've got x squared, this becomes 4, this becomes minus 8 minus 12 equals 0. 4 minus 8 is negative 4, minus 12 is negative 16, so I've got x squared minus 16 equals 0. Now, there's two different ways you can go about solving this. You can think of it as factoring, but I'm sure most of you are thinking, oh, I'll add 16 to both sides. And that would be called solving by square roots. Regardless of which method you take, you should get the same answers. I'm currently going to add 16 to both sides. The reason I can do this is there's no b value. There's no bx in the middle of the ax squared and c. So since there's no middle term, I'm adding 16 to both sides, and I get x squared equals 16. In order to solve here, I take the square root of both sides, and I get x equals, and here is the kicker, make sure you write plus or minus when you take the square root. Plus or minus, square root of 16 is 4. So when I plugged in y equals negative 2, I got two answers. So that means my solutions are negative 4, comma negative 2. Remember, negative 2 is the y. Negative 4, comma negative 2. And positive 4, comma negative 2. So we'll recap. I picked out what I was going to eliminate. I made a plan and I eliminated. I solved the remaining equation once I did elimination. I got one value for y. I plugged it into one of my equations. I solved and I got two values of x. So that one value of y is in both solutions with the two different values of x. That's really important to recognize. That one value of y, since I got two x values, they're both in there. All right, so to wrap this up, I am going to go back to Desmos. And I'm going to plug this in. So I've got x squared plus y squared plus 4y minus 12 equals 0. And for my other one, I've got x squared minus 16y squared minus 64y minus 80 equals 0. And here you can see I only have 2 points of intersection. Negative 4, comma negative 2, that was one of my solutions. And my other solution was 4 comma negative 2. And you can see those are the points where these lines are intersecting. The graphs look weird. You're not comfortable with the graph version, but when you actually look on Desmos, you can see that these answers are correct.